Alright, in 4.3 we're going to talk about the graphs of the tangent and cotangent curves. Rather than plotting points like we did in the previous section, though, I just want to show these to you in Desmos. So let's take a look. Oops. So in Desmos. Okay, so let's look at tangent x first. So as you can see, it's it's kind of a crazy function. If you zoom out, it looks like you just see copy after copy of this. Oh, it almost looks like a cubic function, except that it's not quite cubic because it has all of these vertical asymptotes. And let me change the x-axis here so that you can see a little better. So I'm going to change the x-axis so that the step is maybe pi. There you go. Well, I want to see. There you go. So you can see now that you've got these vertical asymptotes at like negative pi over 2 and pi over 2 and 3 pi over 2 and so forth. And that should make sense to you because we know that the tangent function is undefined at those locations, right? Because if you think about it, tangent is sine over cosine. So tangent is going to be undefined whenever cosine is 0. And where is cosine equal to 0? Well, cosine is 0 at pi over 2, and at 3 pi over 2, and at 5 pi over 2, and at negative pi over 2, and so forth. Okay. Now, on the other hand, tangent is going to be 0 whenever sine is 0, because tangent is sine over cosine. So if the numerator is 0, then the function is 0, right? So where is sine equal to 0? Well, sine is equal to 0 at 0, at pi, at 2 pi, and so forth. Another thing to kind of point out about this function is that one complete copy of the function takes place between, for example, negative pi over 2 and pi over 2. And that means that one period of this function is just pi over 2 minus negative pi over 2, or in other words, pi over 2 plus pi over 2, which is pi. So whereas the sine and cosine functions had periods of 2 pi units, the tangent function has a period of pi units. So its period is half that of the sine and cosine functions. Another thing that we can point out is that the tangent function is odd. And remember that that means that if we fold the top half of this graph over to the bottom half, and then if we fold the right half onto the left half, then the quarters will match up. So imagine taking this branch, flipping it over, and then flipping it to the left. Well, it's going to coincide with this branch, right? So this is an odd function. That makes this an odd function. So it is symmetric with respect to the origin. What else do I want to point out about this? I think that pretty much does it, right? Tangent's 0 whenever sine is 0. It's undefined, or in other words, has a vertical asymptote whenever cosine is 0. It's an odd function. And actually, here's another way to see that, right? Tangent of negative x is sine of negative x over cosine of negative x. But sine of negative x is just negative sine x, since sine is odd. And cosine of negative x is just cosine of x, since cosine is even. And that means that tangent of negative x is negative tangent x. Okay, so it's an odd function. It looks like this, it's standard period, I guess. So when we go to plot, when we go to graph translations and transformations of the tangent function, the first step is always to put the argument between. Put the argument within the sort of standard period, I guess. So for sine and cosine, it was between 0 and 2 pi. For tangent, it's going to be between negative pi over 2 and pi over 2. So that's kind of an important key to remember, is that that's what, when you do the very first step of graphing these things, you're going to say, you know, put the argument between negative pi over 2 and pi over 2, instead of putting it between 0 and 2 pi, right? Anyways, that's tangent. Now cotangent, you can imagine, is going to be pretty similar because cotangent is cosine over sine, right? So it's going to be 0 whenever cosine is 0 and undefined whenever sine is 0. So that means it's going to have asymptotes in exactly the locations where the tangent function is 0, right? Anyway, we'll take a look at a graph of this here in a second. But cotangent is an odd function, just like the tangent function, and it looks like this. So it looks a lot like the tangent function, but whereas the tangent function is increasing, the cotangent function is decreasing. Okay. And its standard period, rather than being from negative pi over 2 to pi over 2, is from 0 to pi. And I'll show you why. So let's look at the cotangent function in Desmos. Okay, so here's the tangent function. Again, you can see one copy of it takes place between negative pi over 2 and pi over 2. But take a look at the cotangent function. So you're not going to get, I mean, I guess you kind of do get one copy between negative pi over 2 and pi over 2, but you've got this asymptote in the middle, so that's not very convenient. So instead we just take the standard period to be between 0 and pi, and then you get one full copy of this almost cubic looking thing. But you'll notice now that you've got asymptotes at 0, pi, 2 pi, negative 2 pi, so forth. Okay, and you just get copy after copy after copy of this thing. Okay, so I think that's all I have to say by way of introduction to these functions. Let's just practice graphing some of these things. So I'm going to give you 6 examples. So I think 3 of each probably. Okay. So let's graph and then state the period. One thing that we won't do is we're not going to state the amplitude. And the reason that we're not going to state the amplitude is because the tangent and cotangent functions both have range negative infinity to positive infinity. So there's no sense in talking about an amplitude, right? Because remember, the amplitude is like the difference between half the distance between the maximum and minimum values, but tangent and cotangent don't have maximum or minimum values, so it makes no sense to talk about amplitude. But anyway, so let's graph and we'll state the period for the following. Let's do f of x equals tangent of 3x. Okay, so this starts off very similarly to the way that we graphed the sine and cosine functions. We're going to take the argument here, and we're going to place it between the lower and upper bound of the kind of standard period of the function. And what's different is that the standard period for tangent is different. So we're not going to place this between 0 and 2 pi. We're going to place it between negative pi over 2 and pi over 2. And this time I'm just using strict inequalities rather than inclusive ones because, you know, the tangent function is undefined when x equals negative pi over 2. Or in this case, when 3x equals negative pi over 2. But anyway, let's finish solving this now. So we would divide through by 3, right? And get negative pi over 6 is less than x, which is less than pi over 6. So that's one period. Okay, that's one period of the function. Now, if you wanted to know how long that period was, and we do, right, because we were asked to state the period anyway, then you would take upper bound minus lower bound, right? So it would be pi over 6 minus negative pi over 6. That's pi over 6 plus pi over 6, 2 pi over 6, or in other words, pi over 3. Right, so the period is 2 pi over 3. We already know that that's the length of the period. But where it's going to fall graphically is between negative pi over 6 and pi over 6. So then if you're thinking about what to add, you should divide this period into 4 parts. Okay, so we're going to divide pi over 3 by 4, and we would get pi over 12 doing that. So, so let's make our little table of values now. I'm going to start at negative pi over 6, and then I'm going to add a pi over 12. So negative pi over 6 is the same as negative 2 pi over 6, so if I add pi over 12, I'm going to get negative 1 pi over 12. And if I do it again, I'll get 0. And then if I do it again, I'll get pi over 12. And if I do it one more time, I end at pi over 6, just exactly where I want to be. Okay. Now to figure out the output values here, you can plug these values back into the tangent function. Now, at negative pi over 6, we're going to have an asymptote. And you can tell that because if you plug in negative pi over 6, you get 3 times negative pi over 6 is negative pi over 2, and tangent of negative pi over 2 is undefined. If we plug in negative pi over 12, we'll get negative pi over 4. Tangent of negative pi over 4 is negative 1. If we plug in 0, we're going to get 0. If we plug in pi over 12, we're going to get positive 1. And if we plug in pi over 6, we're going to get undefined. This is the standard kind of pattern for tangent, right? You have asymptotes on the endpoints, I guess, and then negative 1, 0, and 1 in the middle. Let's graph this thing now. So remember, the labels are really important, right? They're really what makes the graph. So, asymptotes here and here. 0 here, negative 1 there, positive 1 there, and then you draw kind of like a cubic looking thing. Okay? And there's the tangent function. That's just one period, right? That's just one copy. This thing will repeat over and over and over again, right? In both directions. But that's the idea. That's really sloppy. But you get the point. Okay. So that's that one. Let me give you one to work on. See if you can do the same thing this time for cotangent. So we'll do f of x equals cotangent of 2x. Just remember, the period is from 0 to pi on cotangent, not from negative pi over 2 to pi over 2. So I'll let you work on that. Okay, here's my solution. So the period's pretty easy to tell on this one, right? It's just pi over 2. And by the way, maybe I should pause to say, you can tell what the period's going to be the same way that you could tell it for sine and cosine, right? It's if you're multiplying x by some number, then you divide the normal period by that number, and that's the period of the new function. So for in this case, we found that the period was pi over 3. Well, look, we know that tangent has a period of pi units, and since we're multiplying by 3, we would divide pi by 3 and get pi over 3 for the period of that function. And in this case, we found that the period is pi over 2, and that makes sense, right? Because it's just pi divided by 2. So that's the period. Then we split that into 4 parts. To tell us how much to add. So we're going to add pi over 8. So starting at 0, I'm going to add pi over 8, and again, and again, and again. 4 pi over 8 is pi over 2. Okay. For tangent, so for cotangent, cotangent of 0 is undefined. So it's going to be similar to the tangent function. You're going to be undefined at the endpoints. But then instead of being increasing, so instead of going negative 1, 0, 1, it's going to go the other way around. It's going to go 1, 0, negative 1. But we can verify this, right? If you just plug in the values, like if I plug in pi over 8 times 2 is pi over 4. Cotangent of pi over 4 is 1. If I plug in 3 pi over 8, 2 times 3 pi over 8 is 3 pi over 4. Cotangent of 3 pi over 4 is negative 1. Right? If I plug in pi over 4, I get 2 times pi over 4 is pi over 2. Cotangent pi over 2 is 0. Right? And undefined on the endpoints. Okay, so that's that. Now let's graph it. Oh, I guess I didn't need all this stuff on the left-hand side. That's okay. So pi over 8, pi over 4, 3 pi over 8, pi over 2. Okay, so at 0, I've got an asymptote, and at pi over 2 I have an asymptote as well. At pi over 4, cotangent is 0. At 3 pi over 8, cotangent is negative 1. And at pi over 8, cotangent is positive 1. And so there you go. I've got almost the same looking graph as the tangent function, but falling instead of rising. And just like with the tangent, of course, this thing's going to continue on in both directions. Okay, so that's what that thing looks like. Let's make it a little more interesting. So let's do f of x equals negative 3 tangent 1/2 x. Okay. As always, right, you can pause this and work on it on your own before you watch my solution. I'm just going to go ahead and work this out, though. Okay, so negative pi over 2 less than 1/2 x less than pi over 2. Multiply through by 2, and negative pi is less than x is less than pi. So the period now is going to be, pi divided by 1/2, or in other words, pi times 2, so 2 pi. And that makes sense because maximum minus minimum, right? Pi minus negative pi is 2 pi. So the period here is 2 pi. So how much should we add? Well, we should add 2 pi divided by 4. That's going to be pi over 2. So let's do it. Starting at negative pi, I'm going to add pi over 2. Until I get back to pi, my endpoint. And there should be 5 values there now. I know it's going to be undefined at the ends, and then it's going to go negative 1, 0, 1. Oh, but except I'm multiplying by negative 3, right? So instead of negative 1 times negative 3 is positive 3. 0 times negative 3 is still 0. 1 times negative 3 is negative 3. So that's actually what I'm going to end up with. Okay, let's graph it. Now, if you're nervous about this, go ahead and use your calculator. Just plug these values in, right? But anyway, let's graph. Okay, so vertical asymptotes here and here. And then I'm going 3, 0, negative 3. Okay, so that's that one. Okay, let's do another. Okay, 2 plus tangent x. Well, on this one we're not even multiplying by anything here, right? We know that x is between negative pi over 2 and pi over 2. Oops. So, so the period is pi. Right? There's been no horizontal stretching or anything like that. Right, so the period is pi, so you're going to add pi divided by 4, in other words pi over 4. Starting at negative pi over 2. In fact, the only thing that's different about this function from just the normal tangent function is that it's been shifted up 2 units. But when you take an undefined value and you add 2 to it, well, it's still undefined, right? So the only values that change are these 3. So usually I'm starting at negative 1 and then going to 0 and then going to 1. But I'm going to be adding 2 each time. So negative 1 plus 2 is 1, 0 plus 2 is 2, and 1 plus 2 is 3. Okay. Okay, so asymptotes there and there, and then we've got 1, 2, 3, like that. So I'm going to extend this just a little bit. Okay, so what you end up with looks something like that. Okay, so there's that one. 2 more. Let's throw some phase shifts in there. Okay, so f of x equals negative cotangent of x plus pi over 4. So we're going to start the same way. We're going to trap this within the standard period. So that would be between 0 and pi in the case of the cotangent function. Okay, so if we go through and subtract through by pi over 4, that would be 3 pi over 4, right? But notice that the period doesn't change because we haven't multiplied x by anything. The period's still just pi. You could do 3 pi over 4 minus negative pi over 4. That's 3 pi over 4 plus pi over 4, which is 4 pi over 4, or in other words, pi. Right? So the period's pi. That means that you're going to be adding pi divided by 4, or in other words, pi over 4. So starting at negative pi over 4. Let's do it. So if I add pi over 4, and then again, and then again, and then again, I've got my 5 points, and they start and stop where they should. And now if I plug these in, I know that I'm going to be undefined on the ends. And then in the middle, cotangent usually goes, it's a decreasing function, so it usually goes 1, 0, negative 1. But this is negative cotangent, so I'm going to flip the signs on all of those, right? So it usually goes 1, 0, negative 1. But because I'm multiplying by a negative there, I'm going to actually have a negative 1 here and a positive 1 there. Okay, and that's all there is to that one. Let's go ahead and plot the points. Okay, asymptote there and there. Okay, so I guess we should have 0, -1, pi over 4 is 0, and then pi over 2, 1. Okay, and that's that. Okay, so one more, last one. Let's do f of x equals -2 plus cotangent of x minus pi over 4. Alright, so we're going to say x minus pi over 4 is between 0 and pi, and then solve for x. So x has to be between pi over 4 and 5 pi over 4. But 5 pi over 4 minus pi over 4 is 4 pi over 4, which is pi. So the period is still pi. And you could tell that because you're not multiplying x by anything. Okay, so the period is still pi, which means you're going to be adding pi over 4, starting at pi over 4. Okay, and then if we plug these things into the function, we know we're going to be undefined here and here. And then we also know cotangent usually goes, it's a decreasing function, so it usually goes 1, 0, -1. But in this case, we're also subtracting a 2 from that value. So 1 minus 2 is -1, 0 minus 2 is -2, and -1 minus 2 is -3. Alright. Okay, so we've got pi over 4, pi over 2, 3 pi over 4, pi, and 5 pi over 4. And -1, -2, -3. Okay, so we've got asymptotes here and here. Pi over 2, -1, 3 pi over 4, -2, pi, -3. So that's what that one looks like. Okay, so that'll do it for the tangent and cotangent functions. In the next section we'll talk about secant and cosecant.